Dear students, welcome to section 8 of Matrices. In this section, we are going to discuss a new topic. It is not a new topic actually. It is a new type of question. Application of mathematical induction to matrices. What is actually mathematical induction? That is studied in +1. If there is an expression involving natural numbers, then that result we can verify by using mathematical induction method. It consists of 3 steps, right? In step 1, we are to show that result is true for n equal to 1 or n equal to 2. It is better n equal to 1. In second step, we are to assume that result is true for n equal to k. And in third step, we are to show that result is true for n equal to k plus 1. Okay. In matrix also, you can expect some questions or expression involving natural numbers that you have to prove by using mathematical induction. So you will understand when we are doing some questions. Okay. So consider one question. This type of question you can expect for 4 marks. So let A equal to, if A equal to a matrix 1, 1, 1, so 3 by 3 square matrix, all elements are 1. Show that A raised to n equal to 3 raised to n minus 1, 3 raised to n minus 1. So again a 3 by 3 matrix, all elements are 3 raised to n minus 1. Now this result you have to prove. So it's an expression involving natural numbers. So we have to prove by using mathematical induction. So what is our step 1? Step 1, we have to show that result is true for n equal to 1. So let n equal to 1. Substitute n equal to 1 in this equation. So left hand side we will get a raised to 1. What about right hand side? 3 raised to 1 minus 1. What is 3 raised to 1 minus 1? 3 raised 0. 3 raised 0. All elements will be 3 raised to 0. Right. All elements will be 3 raised to 0. Now what is 3 raised 0? Any number raised to 0 equal to 1. So this will be equal to 1, 1, 1, 1, 1, 1, 1, 1, 1. We'll get. Now what is this matrix? Is actually our question. So right hand side is A and left hand side is A raised to 1. A raised to 1 equal to A. It is true. Therefore, result is true when n equal to 1. So that is our step 1. Now you have to go for step 2. What is step 2? We have to assume that. Assume that result is true for n equal to k. That means when n equal to k, left hand side will be a raised to k. That is equal to 3 raised to k minus 1. 3 raised to k minus 1. All elements will be 3 raised to k minus 1. Second row. 3 raised to k minus 1. Third row. All elements will be 3 raised to k minus 1. Okay. We assume that result is true for n equal to k. Now in step 3, we want to show that result is true for n equal to k plus 1. So we will write like this. First we will check what we want to prove. We want to show that a raised to, when n equal to k plus 1, what is left hand side? A raised to k plus 1 is equal to, substitute n equal to k plus 1 on right hand side. So it will be 3 raised to k plus 1 minus 1. What is k plus 1 minus 1? K plus 1 minus 1 equal to k will get. So a raised to k plus 1 equal to matrix 3 raised to k are to get. All elements should be 3 raised to k. Right? 3 raised to k. So when n equal to k plus 1, we have to show that a raised to k plus 1 equal to a 3 by 3 matrix with all elements as 3 raised to k. This one you have to prove by using step 1 and step 2. Proof I will write here. A raised to k plus 1. What is a raised to k plus 1? Is equal to a raised to k into a. We can write like this. So now what is a raised to k? A raised to k equal to, by step 2, a raised to k equal to 3 raised to k minus 1. 3 raised to k minus 1. 3 raised to k minus 1. All elements you have to write as 3 raised to k minus 1. It's a lengthy question, so its mark is 4 marks. Okay. It is a lengthy question, so we can expect for 4 marks. And A equal to all elements 1. Now we have to multiply these two matrices. So 3 by 3 matrix, again a 3 by 3 matrix. So what about A11? I will write all elements will be same, right? So I will find A11 first. A11, in order to get A11, you have to multiply first row and first column. So 3 raised to k minus 1 into 1, that is 3 raised to k minus 1 plus 3 raised to k minus 1 plus 3 raised to k minus 1 into 1, 3 raised to k minus 1. Adding 3 raised to k minus 1 3 times, that is 3 into 3 raised to k minus 1. Now what is 3 into 3 raised to k minus 1? A raised to m into a raised to 1 is a raised to m plus n. That result you have to use. So you will get 3 raised to k. Same way, if you are finding A12, it will be 3 raised to k. A13, it will be 3 raised to k. So all elements will be 3 raised to k. So we'll get a matrix like this. 3 by 3 matrix with all elements as 3 raised to k. Right. 3 raised to k. That means the result is true for n equal to k plus 1. This one you have to prove. We got this answer. So, since it is true for n equal to 1, n equal to k and n equal to k plus 1, it is true for all natural numbers. Like this, you have to prove an expression involving natural numbers. Okay. Now, consider second question. If A equal to matrix 3 minus 4, 1 minus 1, then prove that A raised to n equal to 1 plus 2n minus 4n, n 1 minus 2n. This is also an expression involving natural numbers. So we have to prove by using mathematical induction. So we'll go for our first step, step 1. Let n equal to 1. So we'll get left hand side as A raised to 1. What about right? 1 plus 2 into 1, that is 3 will get. Then minus 4 into 1, minus 4. Then n equal to 1. Then 1 minus 2 into 1, 1 minus 2 equal to minus 1. This is our A, our question. So we'll get A raised to 1 equal to A. So result is true when n equal to 1. Now, step 2. Assume that result is true for n equal to k. Result is true for n equal to k. That means A raised to k equal to 1 plus 2k. 1 plus 2k minus 4k k 1 minus 2k. Now we want to show that result is true for n equal to k plus 1. That is our step 3. So we'll write like this. We want to show that result is true for n equal to k plus 1. That means A raised to k plus 1 is equal to, right hand side you have to substitute n equal to k plus 1. 1 plus 2 into k plus 1 minus 4 into k plus 1. Then k plus 1, 1 minus 2 into k plus 1. This result you have to prove. Now, take its left hand side. A raised to k plus 1, that is equal to A raised to k into A. Now, here you have to substitute value of A raised to k and A. Then you have to multiply. So, what about A raised to k? A raised to k equal to 1 plus 2k minus 4k, k 1 minus 2k into A. A is 3 minus 4, 1 minus 1. This you have to multiply. So what about A11? A11 will be 1 plus 2k into 3. That is 3 plus 6k. 3 plus 6k. Then minus 4k into 1. Minus 4k will get. That is A11. Now A12. First row, second column. Minus 4 into 1 plus 2k. That is minus 4 minus 8k. Then minus 4k into minus 1 plus 4k. That is A12. Now A21, second row and first column you have to multiply. K into 3. That is 3k. Then 1 minus 2k into 1 plus 1 minus 2k. Okay. Now A22, second row, second column. Minus 4 into k. Minus 4k. Then 1 minus 2k into minus 1. That is minus 1 plus 2k. Now yes, you have to simplify. So what will you get? 3 plus 6k minus 2k. 6k minus 4k, 2k. So we get 3 plus 2k. Then minus 4 minus 8k plus 4k. Minus 4k will get. Then here this will be k plus 1 because 3k minus 2k, k plus 1. Now minus 4k plus 2k minus 2k minus 1 will get. Now we have to verify whether this answer is equal to this answer. So A11 first we can check. 1 plus 2 into k plus 1. If we expand this one, what will we get? 2k plus 2. 2 plus 1, 3 will get. That means 2k plus 3 will get. So these two are same. So in place of A11, we can write 1 plus 2 into k plus 1 because these two are equal. Now from these two expressions, we can take minus 4 as common. So if you take minus 4, remaining will be 1 plus k. Here you are getting answer directly. So now k plus 1. So this is already k plus 1. Now you have to check whether these two are equal. If you expand this one, what will you get? Minus 2k minus 2. Minus 2k minus 2. That is minus 2k minus 2 plus 1 is minus 1. Minus 2k minus 1 will get. Here also it is minus 2k minus 1. So in place of minus 2k minus 1, we can write 1 minus 2 into k plus 1. That means result is true for n equal to k plus 1. Since it is true for n equal to 1, n equal to k and n equal to k plus 1, hence it is true for all natural numbers. Okay. Consider another question. It's an important question. A equal to cos theta sin theta minus sin theta cos theta. Then show that A raised to n equal to cos n theta sin n theta minus sin n theta cos n theta. This is also an expression involving natural numbers. We have to use mathematical induction. So what is our step 1? Step 1, n equal to 1. So left hand side will be a raised to 1. That is equal to cos n1, cos 1 into theta, that is cos theta, sin 1 into theta, sin theta, minus sin 1 into theta, minus sin theta, cos 1 into theta, cos theta. This is our a. So we'll get a raised to 1 equal to a. So result is true for n equal to 1. Now step 2. Assume that result is true for n equal to k. This we are assuming only. So we'll get left hand side as a raised to k equal to right hand side cos k theta sin k theta minus sin k theta and cos k theta will get. Now we want to show the result is true for n equal to k plus 1. That is our step 3. Step 3. We want to show that. We want to show that a raised to k plus 1 is equal to cos, substitute n equal to k plus 1 on right hand side. We get cos k plus 1 into theta sin k plus 1 into theta minus sin k plus 1 theta cos k plus 1 theta. So take its left hand side, that is a raised to k plus 1, that is equal to a raised to k into a. Now what is a raised to k? A raised to k equal to cos k theta sin k theta minus sin k theta and cos k theta into a. A is cos theta sin theta minus sin theta cos theta. Now you have to multiply these two matrices. Since both are 2 by 2 matrix, your answer will be a 2 by 2 matrix and elements will be like this. A11, for getting A11 you have to multiply first row and first column. So you will get cos k theta into cos theta, sin k theta into minus sin theta, that is minus sin k theta into sin theta. Then A12, first row, second column. So we'll get cos k theta sin theta plus sin k theta into cos theta. Right. Now A21, second row, first column. It is minus sin k theta into cos theta. Cos k theta into minus sin theta. Minus cos k theta into sin theta. At last A22, second row, second column. Minus sin k theta into sin theta plus cos k theta into cos theta. So I'll read elements once again. Cos k theta minus sin k theta sin theta. Cos k theta sin theta plus sin k theta cos theta. This is minus sin k theta cos theta minus cos k theta sin theta. Last one is minus sin k theta sin theta plus cos k theta cos theta. So here you have to use trigonometric identity. Now what about A11? Just like cos A cos B minus sin A sin B. Now what is cos A cos B minus sin A sin B? It is cos A plus B. So in place of A we have k theta, in place of B theta. So A1 will be cos A plus B, that is cos k theta plus theta. Right. Now what about A12? Cos k theta sin k theta cos theta. Like that one formula is there. Sin A cos B plus cos A sin B. Sin A cos B plus cos A sin B. Sin A cos B plus cos A sin B is sin A plus B. So we'll get sin A plus B. A means k theta, B equal to theta. Now this element, take minus from these two terms. If you take minus, what is your answer? Sin k theta cos theta plus cos k theta sin theta, just like sin A cos B plus cos A sin B. So minus of sin A plus B means sin k theta plus theta will get. Now last element. So first you take this element, that is cos k theta minus sin k theta sin theta, just like cos A cos B minus sin A sin B. Cos A cos B minus sin A sin B is cos A plus B. So you will get cos A plus B. Cos A plus B. Last step I will write here. So we will get, you can take theta common from this bracket. So our answer will be cos k plus 1 into theta, then sin k plus 1 into theta minus sin k plus 1 into theta. The last one is cos k plus 1 into theta. So result is true for n equal to k plus 1. Hence it is true for all natural numbers. Okay. Now we can do one more question. If A and B are square matrices of same order such that AB equal to BA. So given that it is commutative, AB equal to BA, then prove that by induction, that A into B raised to n is equal to B raised to n into A. So by using this condition, you have to prove that A into B raised to n is equal to B raised to n into A. So it's also an expression involving natural numbers. So we'll go for induction method. Step 1. Take n equal to 1. So that expression becomes A into B raised to 1 is equal to B raised to 1 into A. That is AB equal to BA. Given that AB equal to BA, so result is true for n equal to 1. Now, step 2. Assume that it is true for n equal to k. That means A into B raised to k is equal to B raised to k into A. Now, step 3. We want to show that it is true for n equal to k plus 1. That means A into B raised to k plus 1 is equal to B raised to k plus 1 into A. Like that you have to prove. So take its left hand side. A into B raised to k plus 1 is equal to A into B raised to k into B. Right. B raised to k plus 1 is B raised to k into B. Now you have to use associative property. So A into B into C equal to AB into C. So by using associative property, we will get A into B raised to k into B. Now what is A into B raised to k? By step 2. A into B raised to k equal to B raised to k into A. So in place of A into B raised to k, we can write B raised to k into A into B. So again by associative property, what will you get? B raised to k into AB will get. Now AB is equal to BA. It is also given. So we will get B raised to k into, in place of AB, we can write BA. Because given it is commutative, so you have to use associative property once again. So we will get B raised to k into B into k. Now what about B raised to k into B? B raised to k into B is B raised to k plus 1. So B raised to k plus 1 into A will get. So A into B raised to k plus 1 is equal to B raised to k plus 1 into A. So result is true for n equal to k plus 1. Hence it is true for all natural numbers. So we can conclude today's section. In the next section, we can do more problems. Okay.